For about 55 years now, the National Aeronautics and Space Administration, also known as NASA, has been working to improve our everyday lives. Interestingly enough, technologies used hundreds of miles from Earth may be sitting by your side right now. This is known as a spinoff, which is in simple terms a technology that has been repurposed for a different use. NASA spinoffs, respectively, are technologies created for use in outer space that now have been incorporated for use on Earth. Spinoffs have become a part of our everyday common practices and integrate into our society in all aspects of life. The Phoenix lander completed its mission to Mars in 2008. As seen in its voyage, a trip to Mars can take up to 10 months. Covering 423 million miles, the most important distance is merely the last fraction, which incorporates the EDL, or Entry, Descent, and Landing phase. Here, the Phoenix must pierce through the atmosphere of Mars, reduce its speed from 12,750 miles per hour, and find a flat area for safe and easy landing. The final part of this process is quite possibly the most difficult one. The reason for this is that the Phoenix is not equipped with the real-time terrain mapping camera. In other words, it is hard for the spacecraft to find a suitable landing spot because the surface of the exact region where it will land is not completely known. In fact, only data found from previous explorations is available for the mapping of what the landing area will look like. The evident problem here is that without such cameras, capable of producing real-time 3D images of planetary terrain, the chances of the lander to incur an accident are very probable. As a matter of fact, only 5 of 13 such attempts to land on Mars have been successful ones. With that said, NASA is exploring new terrain sensing technologies which can be used to show a more detailed image of a spacecraft's surroundings and allow for navigation to a safer landing zone, free of rocks and other hazardous surfaces, and increase the probability of a successful journey. In 2006, Advanced Scientific Concepts Incorporated received a Small Business Innovation Research Award for the purpose of evaluating its 3D flashlight detection and ranging video camera, also known as LIDAR. This camera uses a near-infrared laser pulse to light up an area in front of the lens, which is useful here as it makes it easy to identify any changes in altitude of the surface due to rocks or other materials. Next, the pixels in the camera measure the time it takes for the photons to go from the camera to the surface and back, providing a precise distance measurement. Also, moving at extreme speeds, it is important to remove all motion blur from the photo. This is done by producing an image which has tens of thousands of points that are all taken at the same time, and therefore eliminate all possible movement imperfections. Later, this complex device was taken to NASA, which enhanced it even further to be space-ready. Such innovations by NASA include the product's small size, lightweight, and enhanced performance to suit tougher conditions like high speeds and extreme temperatures. The 3D light video camera can be applied commercially in many ways. From surveillance systems to being mounted on airplanes, cars, and trucks, the Spinoff is surely the best one. This groundbreaking machine has the power to help almost any vehicle with collision avoidance and even navigation. If applied to cars and trucks, the camera would be useful because it could display the distance between the vehicle and its surroundings. This display of distance could be relative in the sense that objects that are far away could be colored green, while objects that are close could be colored red. In addition, the monitor would also display the speed of objects to help the driver better understand what is going on around the vehicle. Plus, according to the Advanced Scientific Concepts Incorporated of Santa Barbara, California, these cameras could come in about 7 years standard on top-line vehicles. Thomas Laux is the Vice President of Business Development at the ASC. He states that there is a future within NASA and certainly outside of NASA for this technology. In summary, a camera that was first made to help spacecrafts land on Mars is also very usefully applied in such areas as vehicle safety. Thus, it is clear to see that the ASC LIDAR camera is the best spin-off because, after all, everyone wants to feel safer on the road. And with this great camera, safety and peace of mind are just one step closer, not to mention all the accidents that would be prevented and lives that would be saved.